is not my favorite, but it doesn't really have a lot of input on the rest of it. Um, it's a calculation that I'm never gonna ask you to do, which is great. But you do need to know how it affects other things, so that's what we're gonna focus on, is what I would actually want. Okay, so it's confusing, and you'll be happy because in the CPM book, they used to make you like derive the formula for this and stuff, and then I realized that College Board never actually asked you to calculate it, so we don't have to worry about all that. So we get to do kind of light today, which is great. Okay. Power is a calculation that researchers like to make before doing a hypothesis test to see if it's worth doing. I will never ask you to calculate power unless I ask you something silly in a minute, but I'll show you. Okay. Power is a conditional probability. It's the chance that we will find convincing evidence for the ha, meaning reject the ho, given that the ha is actually true. So this is meaning you're doing the right thing. You're rejecting the ho appropriately. Basically, the probability that you won't commit a type 2 error. So this is saying power is the conditional probability that you'll reject the ho properly, which is great. Okay, I'm not, again, going to teach you how to calculate it, but you do need to know what it is and how it can be increased. Now, I bet you guys can guess one of the ways that we could increase power because it's the answer for every single question in stats. What's a way that we could increase power? Just take a wild guess. Increase sample size. Yes, you have it. Increasing the sample size means that you're more sure of your result, which means that your test has more power. Okay, I'm going to give you the second one. You can also increase power by increasing alpha, because that makes it easier to reject the ho. Okay, this comes with a price though. If you increase alpha, it will make it easier to reject the ho, but then you have a higher chance of committing a type 1 error. So rejecting the ho when you shouldn't have. Okay, and then the third one is your null and alternative values are farther apart. If they're farther apart, it's easier to detect. Because of a larger z-score. Okay. As amazing and wonderful as all that is, I hope that you guys have some room. We're going to draw the arrow diagram. And this is the thing that I really need you to remember. So the arrow diagram is going to be the thing that I'm going to ask you to refer to in your brain when and those like MCQs where I'm like, what affects what? What affects what? The arrow diagram is the thing that you're going to need to know. Okay, the first arrow is going to be going up, and that's power. So my little diagram, what I'm going to do is I'm going to put all of the things that go in the same direction. So what I'm saying is if I increase power, and power is a good thing, right? We like to have power. So increasing power is increasing alpha. Increasing alpha and increasing power They go in the same direction. Increasing sample size. Sample size goes up, alpha goes up, power goes up. These things all go in the same direction. Now, these are not a good thing, but they also increase. Probability of a type 1 error also goes up. Okay, so since you just took the test and you understand what MCQs are like, well, I would say something like, if I increase alpha, would it A, increase power, B, decrease power, C, increase sample size, D, decrease sample size, whatever I'm saying there. But you need to know all four of those things go in the same direction. The only one that goes in a different direction is the probability of type 2. He goes in the opposite direction of everybody else. But that's really the only thing you need to remember. Probability type 2 does not play nice because type 1 and type 2 have an inverse relationship. So as one gets bigger, the other one gets smaller. Everybody else goes with probability of type 1. Put a little star next to that or something. That's something you're going to want to come back and look at later. Remember who affects what and which way. And everybody goes the same way, except probability of type 2, he goes the opposite way. Okay, now we're going to do our power sentence. This is the rest of the notes, by the way. Okay, so we're gonna do 3 things here. None of them are gonna be super long, it's gonna be awesome, and then we're gonna be done. Okay, now interpreting the power, we're gonna actually go back to the previous example. Um, while you're still finishing up writing it, I'm gonna read it to you and then I'll put it up on the screen. This is from section 9.1A. A company knows that its regular AAA batteries last 30 hours, but would like to test if they last longer. The company selects an SRS of 15 AAA batteries and uses them until they are drained. The sample mean lifetime was X bar equals 33.93 hours. Okay. So interpret the power of the test. So we're going to come up here to my recipe sentence. It says if the true. Okay, now in this problem right here, are we working with proportions or means? Means, right? And I'm not going to put light bulbs. Definitely batteries. Okay, so if the true context, my context is mean lifetime of the batteries is P equals or mu equals, I have mu equals 31 hours, comma, there is a power. Okay, power is right here in this problem. It is 0.762 probability. That there will be convincing evidence of, and then I'm going to slide in my last year's notebook. It says the Ha is mu is greater than 30. Okay, so let's just check it. If the true mean lifetime of the batteries is mu equals 31, there is a power probability that there will be convincing evidence that mu is greater than 30. Okay, now let's actually pause for a second, make sure we understand what this is saying. If all of the batteries for real, their lifetime's 31 hours, then you have a 76.2% chance that you're going to get a sample that's going to allow you to reject the hoe, basically correctly. So you have a 76.2% chance of getting a sample that's going to give you the right answer, is what this is saying. Okay. Find the probability of type 1 and the probability of type 2. Okay, probability of type 1. I'm going to come back over here to your notes from probability of type 1. It says the probability of type 1 error is alpha. Anybody remember what alpha was in this batteries problem? Oh, here it is. What conclusion would you make at the alpha equals 0.05 level? Okay, so probability of type 1 is alpha, which is 0.05, and I got that from the previous notes that we did that has this in it. Okay, now probability of type 2. So I'm going to scroll up in my notes so you can see where that comes from. It says basic power is the probability that you don't commit a type 1 error. That means it's the complement of a type 1 error. Power is the complement of a type 2 error. So that means it's 1 minus power. which is 1 minus 0.762, which is 0.238. Okay, now you probably think I lost my mind because it says describe 2 ways the researchers could increase the power of the test, and I put 3 bullet points. The book only asked us to find 2, but we're gonna find a third one just because we're extra. Also because it really bugged me that there were 3 bullet points up here, and then it only asked for 2 of them. 2 of them are extremely easy though. First one is increase sample size. Second one is increase alpha. So something like what it is 0.05 to 0.10. Okay, now the last one is the hardest to understand, so I didn't want to skip it. Null and alternative values are farther apart, makes it easier, larger Z, are easier to detect. Okay, so what do I mean by that? I have to be honest, when I first started teaching stats, I had to think about this a lot, this particular thing. So for us, I'm going to highlight those 2 things are what I'm talking about. If the true mean is 31 hours, it's going to be harder to find a sample that's over 30, because some of them are going to be under, right? Okay, what if the true mean was 32 hours? Would you probably get more of them that were above 30? What if the true mean was 33 hours? Would you get more of them that were above 30? What if the true mean was 34 hours? Would you get more of them that were above 30? Do you see what I'm saying? Okay, so check anything above mu equals 31. The farther that those things are apart, the bigger chance that you're going to find a sample that shows this. Okay, now prepare yourself for my joke. It is only partially appropriate. If you are somebody who is easily offended by things that are not appropriate, please do not engage yourself in my joke today. Also, the beverage on the screen is grape juice. Okay, this is a slightly inappropriate joke. Makes it better if we can all agree that the beverage is grape juice. Do we all agree that the beverage is grape juice? Okay. Mhm. Grape juice. If the P is low, you must reject the hoe. Yes. I did not make this. I found this on the internet. Someone else, you know. Look at him enjoying the grape juice. Isn't he enjoying it? Do you think he's enjoying it? Yeah. Mhm. It looks delicious, his grape juice. Anyone find me funny? I think it's okay. Okay, good.